This is Dr.G.Vikas. In this session, we'll discuss about Rankine's formula for columns. So 1 by PR is equal to 1 by PC plus 1 by PE. Okay, where 1 by P is, or we can write 1 by PR. Okay, that is called as crippling load by Rankine formula. Okay, PC is crushing load, which is equal to sigma C into A, ultimate crushing stress into cross section area, and PE is a crippling load by Euler's formula. That is, we know this formula pi square E I minimum divided by LE square. So we can write this as 1 by P equal to PE plus PC by PC into PE. And then we can write it as P equal to PC PE divided by PE plus PC, which is equal to PC PE by, if we take PE common here, it is 1 plus PC by PE. We can cancel PE, and we will get this. And then if we substitute PC equal to, we know that PC equal to sigma C into A. So I am substituting sigma C into A here. So 1 plus, again PC is there here. So sigma C into A. And we know PE, that is pi square EI by LE square. And we also know that K is under root I by A. From here we can write I is equal to K square into A. So instead of I, we will write K square into A here. Okay. Right. In this step we have taken LE square to upwards, and then we have written like this, LE by K whole square. Now this is the constant, Rankine's constant A, which is denoted by A or alpha. So we can write in this way, 1 plus P equal to sigma C A into 1 plus A into LE by K whole square, where A equal to sigma C by pi square E, which is Rankine's constant. Okay, this is the Rankine's formula. Now let us see a problem on this. The external and internal diameter of a hollow cast iron column are 5 cm and 4 cm respectively. Okay, this is a hollow cast iron column. External diameter and internal diameter are given. External diameter is 5 cm, internal diameter is 4 cm. And the length of the column is 3 meters. The length of the column is 3 meters. And both of its ends are fixed. So both ends are fixed, top and bottom. So for when both ends are fixed, L equal to L by 2. We know this. So determine the crippling load using Rankine's formula. We need to define this P value. Okay, using Rankine's formula. Take sigma C equal to 550 Newton per mm square and A equal to Rankine's constant A equal to 1 by 1600. Okay, all these given data, external diameter, internal diameter, length, comes to sigma C. Okay, sigma C is also given. Okay, then 550A is given Rankine's constant. So apply Rankine's formula directly. This is a Rankine's formula. P equal to sigma C, A divided by 1 plus small a into LE by K whole square. But here what is A? A is the area. So what is the formula for area of a hollow circular section? Pi by 4 capital D square minus small d square. So from here we can calculate area as 225 times pi mm square. Now what is K here? K is under root I by A. Okay, so under root I means pi by 64, d power 4 minus small d power 4 divided by capital A. So already capital A we have calculated 225 pi, but here substitute d values here. Finally you will get K as 25.625. Substitute all these values in this formula. And instead of LE, we need to substitute L by 2 because both ends are fixed, LE equal to L by 2. So LE will get as 3000 by 2, 1500 mm. So if you substitute all these values, you will finally get crippling load as 123750 newtons. Okay. Now, let us see next problem. From the following data, determine the thickness of cast iron column. Assume both the ends of the column are fixed. Let this given, external diameter is given, internal diameter is not given here. Safe working load is given 600 kN, factor of 50 is 5, ultimate compressive stress is 570 sigma C. Okay. Rankine's constant A is given as 1 by 1600. So this is a figure, both ends are fixed, column external diameter is given, span is length is given, internal diameter is not given. We need to find the T, thickness. Okay, thickness of the cast iron, we need to find this T. So what is the formula for thickness here? We can write here capital D minus 2 times T is equal to small d, right? So from here we can write T is equal to capital D minus small d divided by 2. Yes, right. So here safe load is given as 600 kilonewton, which is equal to 600 into 10 cube Newton. So all these are given data. Okay, length is given, p safe is given, a factor of safety is given, sigma c is given, a is given. Okay, le is both and fixed means l by 2, that is 1500. Okay, now this is the formula. So here to the left side we have p. So p means we can write as p safe is given. How can you find p? We know that p safe is equal to p divided by factor of safety. From here we know factor of safety, so p equal to p safe into factor of safety. So from here we got p, substitute here that p value. Okay, so p is 3 into 10 power 6. Now what is k minimum? K minimum is under root I minimum by a. I minimum is pi by 64 capital D power 4 minus small d power 4. But we don't know small d value. So let us write as it is, capital D small d. Divided by area is pi by 4 d square minus d square. Okay, so I can write this d power 4 minus d power 4 as d square minus d square plus d square. So from here we can cancel this. So from here pi also gets cancelled. So from here we can write k minimum square equal to d square plus d square by 16, or we can write k minimum equal to under root d square plus d square by 16. So from here, so this is actual formula, right? Here we are substituting, instead of p we are substituting 3 into 10 power 6, and instead of area we are substituting sigma c, we are substituting 570, area pi by 4 d square minus d square, and 1 plus a is 1 by 1600, and le is 1500, and k minimum is under root of d square plus d square by 16 and whole square. Okay, now we are getting this one. If we simplify it, we'll get this one, and in the next step what we have done is we need to simplify this. Okay, d square plus d square we are taking here, we are just simplifying it, and taking to the left side we will get this one, and then substituting capital D values in this step, and here simplifying it again we'll get this one. Finally we will get this equation, d power 4 plus 670.1. This equation we get. Now what we are doing is we are substituting d square equal to x. Then we can write x square plus 670 so into x minus 1. So x we will get as the roots are 31163.53 and x equal to minus. So my internal diameter can't be negative, so we can cancel this negative value. Then so x equal to 31163.54, that is x means d square, no? So d square equal to 31163.54. So d is under root 31163.54, that is equal to 176.53. So we got d, so we can calculate t. So t equal to capital D minus d by 2. It is not t, it is 2. So 200 minus 176.53 would put 11.74 mm. Thank you.